Hello everyone, welcome back to lesson number 21, where we're talking about theorems for calculus. In the previous videos, we've talked about derivative theorems, IVT, Rolle's theorem, mean value theorem. And now in this video, we're going to talk about the average value theorem, which is an integration theorem. So the first thing I want to say about this is that if you guys look at what's going on right here, this is the fundamental theorem of calculus, right? So this is the definition, the notation for the fundamental theorem of calculus. This is actually the formula that you're going to use to find the average value. So you're going to integrate from a to b of your function, and you're going to take 1 over b minus a out. And the reason why is if you guys look at this and you found what f of b minus f of a is, all over b minus a, well, this is the average rate of change, right? This is the average rate of change. So the average value is really kind of a hybrid of these two things. Now, I want to just clarify that the average value is not, it is not the average rate of change. For average rate of change, you simply plug in, right? You plug in to your function b, you plug into your function a, all over b minus a. For the average value, you will have to integrate your function to get the f of b and the f of a. So I just want to clarify in saying that they are not the same thing. This is a straightforward substitution. This is going to be an integration. All right, so just clarify that they're very similar, but they're not the same thing. So let's actually show you how to do these questions. Now, the very first example I'm going to show you guys here, example number 9, is just a straightforward, simplistic problem on what to do to find the average value. Now, I will tell all of you that, at least in my class, if you see average, if it's not followed by rate of change, then you will do an average value. So average height, average radius, average whatever is going to be an average value question. So this is going to be an average value question. If you see average rate of change, you will do f of b minus f of a all over b minus a. We do not do that here. We do not do that here. So what is the average height? So we're going to say that the average height is going to be equal to, and so the first thing we're going to do here is we're going to highlight the fact that I have to do 1 over b minus a. So this is our a, this is our b, so we have to do 4 minus 1. So that I put that in red to highlight that that's something we have to remember to do, is 1 over 4 minus 1. So we need that constant on the outside. And I'm going to go ahead and do a 1 to 4 of our function. Or 1 to 4 of our function. So this is the simple setup to find the average value of any particular function. In this case, again, it's the average height. So it's 1 over b minus a, the integration of 1 to 4 of our function. So we can go ahead, and I'm going to keep it in red just to make sure that we're good here. I'm going to go ahead and do 1/3, and then we're going to multiply. We're going to multiply by the integration of this. Well, this is going to end up being x cubed minus, and then the integration of 2x is just going to be x squared, evaluated from 1 to 4. So we even showed you guys really pretty easy examples with this. So we're just going to keep pulling out the 1/3 right now. So we're going to integrate normally, and just the only thing is it's the fundamental theorem of calculus with one extra step, right? It's the fundamental theorem of calculus times 1 over b minus a. That's all this is. It's really all this is. So 4 cubed is going to be 64, minus 4 squared is going to be 16, minus 1 cubed is 1, minus 1 squared is 1. So we always like that because that doesn't mean, ends up being 0. So we have 1/3, and then 64 minus 16 is 48. We already said that's 0. And so 48 over 3 is going to give us 16. So the average height of the function over the interval from 1 to 4 is actually 16. And so really what that is if you were to graph this function on the interval from 1 to 4, and you look at the averages heights of this, the average height of this curve would be 16 units. 16 units. Okay? So that is a simplistic example of how to find the average height. Okay, so for example number 10, it says for the function x squared on the interval from 1 to 4, find a value of c in accordance to the average value theorem. So one of the things that I now want to go back and talk about is this little section right here, where it talks about geometrically, this also has a special meaning to the problem. And so, just without getting into too much detail, when we integrate this, and this again goes back to our average value theorem, we could say that integration of this is going to be equal to some function, f of c, times b minus a. Now again, ladies and gentlemen, if you just look at this, and if I, like, where did this equation come from? Well, f of c is going to be equal to the integration of a to b of f of x dx all over b minus a. And that's exactly where I can now pull that out and do 1 over b minus a. So it's just me rewriting that. But now I want to know what this is. I want to know what the actual function f of c is. So when it's asking you to find a unique number, c, on the interval, then you're going to use this equation right here. All right, which again, is just a hybrid of what that is. And I can show you the both ways of doing this problem, where we can do it the way we just did example number 9, or we can follow the equation. So let's actually, in this video, show you both ways and see which one you like the best. So we're going to use the equation first. Okay, so we're going to use the equation that 1 to 4 of x squared dx is equal to some f of c times b minus a. All right, now the other way to do this actually literally is just to acknowledge that you are doing this. You're doing this first and finding the value. Okay, so these are the same two ways. So, like, I mean, really, it's just do it, but notice that we're setting this equal to f of c. F of c. All right, so we're going to find the value of this, but that's going to be equal to f of c, not what the actual value is. So this, I think, is the same thing. Let's go ahead and just solve it, whichever way you want to do it, but let's go ahead and just look at the left-hand side here. So if I integrate this, I'm going to integrate this as x cubed over 3, evaluate it from 1 to 4. And f of c, we're going to leave that alone, and then I'm going to go ahead and just do a 3 here. And that's the same thing that I can do with you guys here, is that this is going to be, I'm just going to do them side by side. So 1/3, and then we're going to integrate this as x cubed over 3, evaluate it from 1 to 4. So while I'm on this right side right here, I can go ahead and pull out a 1/3. So I can have a 1/9, and it's going to be x to the cubed, evaluate it from 1 to 4. And same thing with what's over here, ladies and gentlemen, is I can divide by 3, right? Divide by 3, which is 1/3. And this is where I'm going to just go to this part right here, because then you see that they're the exact same thing, right? So now it's 1/9, x to the 4th, evaluate from 1 to 4. So this is where we're going to continue on with the problem. So f of c is equal to 1/9, and this is going to be 4 cubed, which is going to be 64, minus 1 cubed, which is going to be equal to 1. So it's going to be 63 over 9, which is equal to 7. So now f of c is equal to 7. So, well, what is f of c? Well, we have to go back here to this. So if f of x is equal to x squared, if I asked you guys what is f of 9, you would say, okay, well, f of 9 is just going to be equal to 9 squared. So f of c should be simply equal to c squared. So c squared is equal to 7. So c in this case is going to be equal to positive and negative square root of 7. However, we want the answer that's on the interval of 1 to 4. Okay? Or in the interval of 1 to 4. And that's one of the things that I actually didn't talk about with the mean value theorem. And I should probably go back and edit that video. But the mean value theorem, you can't include the endpoints. So I don't know why I just really thought about that. But anyways, so that's how you do those questions. And like I said, that is the average value theorem. And I hope that that makes sense to everyone. And I will see you guys back in the next video.